Assalamualaikum warahmatullahi wabarakatuh. So let's continue with inverse Laplace transform. So inverse Laplace transform have three kinds of poles, which is you need to figure out the poles characteristic first. Okay, the first one is if the GS or the function contains only distinct poles. Distinct poles means the poles is real number and the number is different between both pole or between the poles. And the second one here is if GS contains multiple poles. Okay, multiple poles mean the poles is repeated the same number. Okay, so and the last one is GS contains complex conjugate poles. So we need to discuss these three types of poles to do the inverse Laplace transform process. So the first criteria is when the GS contains only distinct poles. So let's say this is the example of the transfer function. The nominator at the upside is called 0. So the 0 in this question is equal to negative 3. Okay, the denominator is called poles. So we need to look first at the denominator where the first poles is equal to negative 1 and the second poles is equal to negative 2. So these both poles is real number and the both poles is different. So this criteria can be categorized into GS contains only distinct poles. Next, all you need to do, the first step is to do the partial fraction. So what is partial fraction? Which is you divide the denominator into the unknown nominator, which is in this case Fs is in this case, okay, sorry, that one. Okay. In this case, I can write like this. Fs is equal to A. A is unknown divided by S plus 1 plus B divided by S plus 2. So you need to find first the value of A and B. So to calculate the value of A and B, there are two methods. Okay, both method I will explain to you. So the first method is by using a formula. Okay, so to find A, okay, you need to copy the whole sets of Fs, which is S plus 1 and then S plus 2. So you know that A, the denominator for A is S plus 1, so that you need to multiply with the denominator of A, and then what is the roots of this first function is S is equal to negative 1. So you can cancel this 1 and then you will get A. Okay, you will substitute S equal to negative 1 inside the questions. So negative 1 plus 2. Okay, when you calculate this one, you will get A is equal to 2. Okay, and then to find B, okay, to find B is you copy the questions. Okay, this formula is used with if the GS contains only distinct poles. Okay, you must remember. Okay, S plus 2. So for B, the roots of B is S plus 2. Okay, the roots is S equal to negative 2. And then you can cancel this one and substitute -2 inside the balance. -2 plus 1. So you will get B is equal to -1. Okay. From this, you can write the transfer function here, Fs, is actually is equal to A is 2 over S plus 1 minus 1 over S plus 2. If you don't like the first method, so you can use the second method, okay, which is by using, I call it compare coefficient. Compare coefficient. Okay, how to do this second method. So you just copy the nominator only. So S plus 3 is equal to A times S plus 2 plus B times S plus 1. So I just make the equation in a one row only, so that I normalize the denominator. So I just copy the nominator, and then I'm want to make a comparison. So I'm just open that, plus 2A plus bs plus b. So this one s plus 3, this one s plus 3, so that I can collection of all the coefficient of time s, which is a plus b, and the rest is 2a plus b. So I can compare this one with the coefficient of that one, and this one with the coefficient of this one. So from that, I can create two down equation, which is a plus b is equal to 1, and 2a plus b is equal to 3. Okay, from the both unknown equation here, you can use your calculator to calculate the unknowns a and b, and you will get the same result as the first method, which is A is 2 and B is -1. Okay, from this, after you do the partial fraction here, you can simply convert the S domain to T domain by refer to the Laplace table. If this one is S kuasa 1, which is S kuasa 1, so 2, and then the shifting is exponent -t. Okay, remember dia punya signage tu kena berbeza. Minus, okay, this one is still S kuasa 1, so S kuasa 1 means unit step, which is constant. So 1, so the depan dia 1, exponent E, -2t. Okay, so this is the answer. Next, the second criteria is the S contains multiple poles. So let's say this is the transfer function, and you can see that this function has 3 poles, where the poles, all the poles is same, which is -1. So in this case, you can write the partial fraction like this: a over s plus 1 cube plus b over s plus 1 square plus c over s plus 1. Okay, so this is the way to write the partial fraction. So the next step is solve the value of a, b, and c. To solve the unknown nominator A, B, and C, of course, it have a formula for that. So to find A, okay, to find A is actually copy s square plus 2s plus 3 over s plus 1 cube, and then time with the denominator of A, which is s plus 1 cube, and then the roots is -1. Okay, so this one is cancel, and then you will get A is equal to -1 square plus 2, -1 plus 3, and then A is equal to 2. Okay, so you will get A is equal to 2. Okay, to find B, because of the roots is the same, which is -1, so you need to differentiate the balance of A, which is s square plus 2s plus 3, and then s is equal -1. It is continue when you want to find C. It is actually the second order differentiation, so 1 over 2 factorial, because it is second order, differentiate second order of A. Okay, so it is same where s is -1. So here B, okay, when you differentiate, you will get 2s plus 2, where s is -1. When you substitute that one, 2 -1 plus 2b is equal to 0. Okay, for C, 1 over 2 factorial, so 2 factorial is equal to 2. Second order differentiation of this one is differentiate this one is equal to 2, and then C is equal to 1. Okay, as you can see here, to get FT from this, okay, from the table, if the signal is ramp T, the S domain is equal to 1 over S square. And if the signal is T square, then the S domain is 2 factorial over S cube. And then you can see here the power of S is cube, so that we know that this is the element of T square in T domain. But you can see here it is already 2, so that 2 over S cube is 2 over S cube is already convert to T square, and then the shifting there is exponent -T, and then plus this one is 1 over S. S mean 1 over S mean unit step, which is constant, and then 1, and then shifting exponent -T. Okay, so this is the answer. Okay, the third criteria of poles, which is GS contain complex conjugate poles. Okay, look at this example. Fs is equal to S plus 1 over S times S square plus S plus 1. So, the S here is one pole, which is S equal to 0. The one pole is 0. And inside the bracket here, we have two poles, which is the poles is in a complex conjugate form. So just leave it as like this, and then you just need to write the partial fraction form of this transfer function, where for the pole S is A over S plus, okay, for the complex conjugate poles, S square plus S plus 1, okay, because of the highest order of S is square, so that you need to write it B S plus C. So, all you need to find now is to find the value of A, B, and C. Now, to find value of A, B, and C, you have no choice rather than you need to use the compare coefficient method. So that in compare coefficient method, you just copy the nominator only with a normalized denominator, something like this. So the partial fraction here, you need to multiply, cross multiply, so that the the denominator is the same, so that you just copy the nominator only, and then you can make comparing the coefficient, whereas I just open first as plus a plus, and then this one is bs square plus cs. Okay, so after this, I need to compare the coefficient for s square, which is a plus b, and then the coefficient of s is a, and then oh sorry, not that, the coefficient of s is actually a plus c, and the last one is no s, which is a. So the left side is s plus 1, so that all you need to compare here is this one is compare with this one. So I will get a is equal to 1, and then this one is actually 1. I will compare with this one, and then a plus c is equal to 1. So when a is 1, c is equal to 0. And then here a plus b here, okay, a plus b here is actually equal to 0, because there are no element s square at the left side, but a is equal to 1 plus b is equal to 0, so that b is equal to negative 1. Okay, from the value of a, b, and c, you can write the partial fraction is equal to a is 1 over s plus b is negative 1 s, uh, c is 0 over s square plus s plus 1. Okay, so actually this is not a good practice of write this one, so I will erase this one, and then I just put it here negative. Okay, so b is negative 1. So this part is actually settled. Okay, actually this part in S domain is 1 over S, so at T domain is equal to 1, right? 1, which means it is unit step, so you don't need to change it yet, but this one is not in a right form yet, and then I need to solve this one, do a slight modification. So I will write this as f1 s first. Okay, so I using a green color to modify s1 s to the form that I can convert to t domain. So this is tips, okay? I will give you one tips. Okay, one tips I use orange. Okay, you need to look at your Laplace table. So just look at the E negative AT cos omega t and E negative AT sin omega t. Okay, for this one, in T domain and in S domain is S plus A equal to S plus A square plus omega square. For the sine with exponent is equal to omega over S plus A square plus omega square. So the tips is if the roots is complex conjugate. Okay, I say if the roots is complex conjugate, it is confirm. Okay, this one is tips. Yeah, confirm that is it is the element of this one and two. Both cos and sine with the shifting element exponent is confirmed in T domain for the complex conjugate roots. So that all you need to do now is here um, to make the roots. Okay, sorry. Here I use yellow. Here I circle this one. The roots here to be the same with this one. I need to modify it. So let's modify the root. So this is I'm using a comparison of the original roots here. I would like to change this configuration into this one configuration. So I need to find the value of A and omega square. So how to find? Just using a compare coefficient method. So I open this first. 2as plus a square plus omega square, and then this is still so here I can compare here the element of s here is equal to 1, right? Okay, and then here with no s here also is equal to 1, so I can calculate 2a is equal to 1 so that a is equal to 0.5. Okay, and then a square plus omega square is equal to 1, so this one 0.5 square plus omega square is equal to 1, so that I will get omega square is equal to 0.75. Okay, from this value, I can okay, I can write that okay, here F1s is actually is equal to S over S plus A 0.5 square plus omega square. Okay, this one. Okay. So, okay, I think I should zoom out this one so that you can see that the element of S here is slightly the same with exponent negative 80 cos omega t. So I need to get this form, but this one is S plus A, right? So I don't have S plus A, but don't worry, we can add, but don't change the original. Don't change the original question so that I can add plus 0.5, the purple one, but I minus again 0.5. Okay, so actually I successful create the yellow one. This one is the same with this one, the yellow one. I'm circle the yellow one here. Okay, which is exponent negative at cos omega t here. But I'm still left negative 0.5. Okay, so need to do a little modification again. And then, okay, this one I don't want to change, so I will maintain it in this form because I already know the time domain form of this one. I already successfully get this one. But for the 0.5 here, minus 0.5 here, okay. Actually, when there are no S element in at the denominator here, it is actually this one, exponent negative 80 sine omega t. But the element omega is supposed to be at the denominator, but I don't have the omega element. But don't worry. And then because of you don't have the element of omega, okay, here omega square is 0.75, so that omega is square root of 0.75. So I would like to have omega at the denominator, so I just add, but don't change. So in order to not change the original value, I just divide again by the same value, so that it is like I just multiply by 1. Okay, so after that, F1 S is actually is S plus 0.5. Okay, this one is no change, don't change this one. 0.75 is omega square, and then minus, okay, I will circle with the yellow one, this one, and this one is not used, so that I will let it 0.5 over square root of 0.75 to be the value, any value that I will multiply with the equation, so that it is 0.75 square root. So I just take what I need, which is omega over s plus 0.5. Okay, sorry, this one square. Okay, plus omega square. So this one and this one, you already know the three-domain form, but actually Fs is 1 over S. This one is 1, so I just write the value of Ft, which is the first 1 over S is 1, and then minus with, okay, this one, don't confuse this one, 1 over S minus, so this one is F1, okay. F1 is this one, so this one is cos, so it is exponent negative 0.5 t cos, so the omega is square root of 0.75 t minus, okay, the yellow one here is actually you just use your calculator to just calculate it to be a number, so it will become 0.57. Okay, just pause the video and you calculate yourself. And then omega over s plus this one, okay, this one square, is actually sign element, so it is exponent negative 0.5t sine omega is 0.75 square root t. Okay, so this is the t domain. Okay, so that's all. This is t domain of this one, of this transfer function. So the third criteria, which is the S contain compact conjugate poles, is the more complicated compared to the multiple pole and distinct pole, right? Okay, that's all the three criteria of poles to do a inverse Laplace transform.